Hello, students. So hopefully you're starting to get the hang of this, and if that's the case, then maybe pause your video and try this one out and then come back and check and see. I see two different people, two different events, and this one looks like it's independent. There's nothing, no team spirit or anything here. So my first event is going to be Tanya and whether she passes or fails her test. So I've got Tanya as my first set of branches. And she's got a 90% chance of passing, which means a 10% chance of failing. So we're going to say pass and not pass because that sounds nicer. And then our second set of branches is for Tony. He has an 85% chance of passing, which means a 15% chance he doesn't pass. And it's the same because these are independent events. Okay, so again, we've got four different outcomes. They both pass. Tanya passes, Tony doesn't. Tanya doesn't, Tony does, and they both don't pass. So only one of them passing is the probability that we have pass, not pass, or not pass, pass. We could also write that as pass, not pass, union, not pass, pass. And that's going to be these two sets of branches here. So that's going to be 0.9 times 0.15 plus 0.1 times 0.85. Can put that in our calculator and get the results. So 0.9 times 0.15 plus, let's try that again, plus 0.1 times 0.85. Okay, 22% chance. Okay, at least one passes. So it's going to be this plus the probability that they both pass. So that's the probability that they do not both fail. So I'm going to write it that way. So I could do this as 1 minus the probability that they both fail, or I could do it as 0.22 plus the probability they don't pass. Either way, I'm going to get the same answer. So let's do 0.22 plus 0.9 times 0.85. And just to show that it's the same, we're going to do 1 minus 0.1 times 0.15, and we get exactly the same result. So I'm going to drag this over here to show them both. So that's 0.985. Tanya passes given at least one has passed. So now I've got my given at least one passed, and that's this answer up here. So that's my denominator. Tanya passes, I've got two different ways Tanya passes with the at least one passed, because down here, here, and here, all three of those are my at least one passed outcome. Tanya passes in two of those. So she's going this route and this route is where she passes. So that's going to end up being, let's drag this out of the way a little bit. So probability of Tanya passing given at least one pass. So we're going to end up with 0.9 times 0.85 plus 0.9 times 0.15. Well, notice that together I could factor out the 0.9 and add these two up, and I'm going to get the same as 0.9 times 1. Because I'm taking both of these routes, that's just Tanya passing. That's a 0.9% over my 0.985 from above. So probability of at least one passing is going to be 0.9 divided by 0.985. And you don't want to leave decimals inside of fractions. So let's go simplify that. Divide by my answer. Oops. Okay. And then because this decimal does not look exact, I'm going to turn that into an exact fraction. So 186 out of 197, or approximately, what did we see there? 0.914. Sorry, yeah, 0.914.